So today we are going to solve a differential equation question. So let's read the question. The solution of differential equation k square d square y by dx square equal to y minus y2 under the boundary condition y equal to y1 at x equal to 0, y equal to y2 at x equal to infinite. So where k, y1 and y2 are the constants, so we need to find out the right answer. So first of all, before starting to solve the question, I want to say Happy Mahastami 2022 as I am preparing the video lecture on this day. Okay, so let's start the solution, and before solve this question we need to learn some concepts. So first of all, what is differential equation? So differential equation is an equation involving derivatives of a function or functions. Okay, so here we can see y is function of x, so here derivative of a function we are seeing, so this is a differential equation. Now differential equations are different types, like differential linear differential equation, non-linear differential equation. So linear differential equations have some criteria, like in this equation dependent variable normally we represent as y, and its derivatives are of first degree, that is the degree of derivatives need to be 1. So here in the linear differential equation, the degree means the power of the highest derivative term. Here highest derivative is d cube y by dx cube, so the power should be 1, not more than 1. And uh, and after removing the function power like dy by dx to the power 2 by 3, we need to remove this function, like we can cube in the both side to remove the function term, like 2 by 3 it is. So if we cube this, then it will be only dy by dx whole square, and radical sign also we need to remove. Radical sign means root over. So after removing the functions and radical sign, if we see the highest derivative term has only degree 1, then it is a linear differential equation, and each coefficient not dependent on the dependent variable. So here these coefficients are there, so this is one, means these coefficients should of derivative terms only. Okay, so here derivative terms is this, so this and this derivative terms coefficient is a1, and it is not dependent on this dependent variable y. So this is a linear differential equation in all aspects. Now let's learn about this nonlinear differential equation. So the equation will be nonlinear if the coefficient of derivative of dependent variable is the dependent variable itself. So here we can see that it is the derivative of a dependent variable and its coefficient is also y. So if one derivative term has a dependent variable coefficient, so it will be considered as nonlinear differential equation. Means it can be more, like this term also can have y in the beginning. Y is dependent variable, so it can be, means if single term single derivative term has a dependent variable coefficient, so it can be considered as nonlinear differential equation. We no need to check other terms. So now the second point is, if the power of derivative of dependent variable is more than 1, then also the differential equation will be nonlinear. So the power also we can see here. This is not the right example. So if we write like this, like t2y by dx square whole square, a1 plus a2 dy by dx will be 0. So this is also an example of non-linear differential equation, because the highest order derivatives power or degree is more than 1. Now let's learn some formulas, because this is required in this to solve this question. Okay, so we can solve this through binomial exponential. How it is solved, we can learn that later. If you want to see how it is solved, you can comment. I shall prepare a separate video for that. So now let's remember these formulas. 1 minus x to the power minus 1 equal to 1 plus x plus x square plus x cube. Like that, the series is there. So now if we remember this, then no need to remember these other things, because if we write simply minus x in place of x, so that I have written here also. So then we can write it in place of x, we can write minus x here also, and minus x square is x square itself. So like that the series we will get. Also 1 plus x to the power minus 2 also we can find out by multiplying these two terms. We can understand this clearly. Similarly, this also, if we replace the x with minus x, we will find the formulas of the series also here. Similarly, you can find out 1 plus x to the power minus 3. What will be the answer? You can comment it out. I shall surely check. Now, what is homogeneous equation? So a homogeneous equation does have 0 on the right hand side of the equation sign. So homogeneous equation always have 0 in the right hand side of the equality sign. So what we have written earlier, like this. So is it a homogeneous equation? Yes, because in the right hand side t it is 0. So what will be in the left hand side and what will be in the right hand side? In the left hand side, always all the terms will be y term, like here d2 y by dx square. So it is here the dependent variable is y. Also here is the dependent variable y. So if any other terms are there, like where only the non-dependent variable x is there, and that we need to write in the right hand side, or any constant also is, if it is there, then we need to write in the right hand side of the equality sign. So as we don't have any constant, extra constants, or any dependent variable extra term, so we are writing 0 in the right hand side. So this is a homogeneous equation. Now non-homogeneous equation, which are the non-homogeneous equation? A non-homogeneous equation has a function of independent variable in the right hand side of the equal sign. So non-homogeneous equation has a function of independent variable in the right hand side of the equal sign. So the like here we have written 1. This is one type of non-homogeneous equation, because in the right hand side, if we see, there is a constant term. Also, if it is function of, not function, if it is like non-dependent variable, independent variable, then also it can be considered as non-homogeneous equation. Now let's solve the question. So what is there? K square d square y by dx square equal to y minus y2, if I'm not wrong. K square d square y by dx square equal to y minus y2. Actually, I practiced many times before preparing this video, so I remember that. So now we can simplify this, how I have told already, that all the y terms need to be in the left hand side and the remaining terms will be the right hand side. So here we can write like this, this dy by dx, we can consider this it as d, capital D. Okay, so d2y by dx square we can write it as d square minus here will be also 1y, sorry for mistake. So we can means consider d by dx as d, capital D, not dy by dx. So that's why we are writing here y. Now minus y2. So if we common the common the y, then what it will be? Sorry, why we are means writing like this. Okay, so k square dot d square minus 1 into y equal to minus y2. Now so it will be in the form fd into y equal to 5. So here phi is the right hand side, this equal signs right hand side terms is represented as phi. Okay. So ज़्यादा ही हो गया. So this is the phi. Okay. So now we need to find out the solution of the equation. So for the solution, if we write y equal to complementary function plus particular integral. So complementary function, if we want to find, so first of all we need to find out the auxiliary equations roots. So here the auxiliary equation we can write k square m square minus 1 equal to 0. So here if we write if we see here, for to write the auxiliary equation we need to write 0 in the right hand side, whatever it is, and the left hand side only here we need to see, and in place of d we can write a constant like m I have written here. So if I solve this, then we will get plus minus 1 by k. So here we can see that the roots are real and distinct. So distinct like 1 by k and minus 1 by k. So the solution is the complementary function will be c1 to the power m1 x plus c2 e to the power m2 x. These are the formulas of complementary function. Means if we get roots real and distinct, then the formula will be like this. There are some other formulas that for that we can create a separate video. Please visit that also. Now let's proceed. Now here we got the m1 as 1 by k into x plus c2 e to the power sorry here you can write minus 1 by k into x. Now this is the complementary function. Now let's solve the particular integral. For any this type of equation, the particular solution will be 1 by ft into 5. So here 1 by ft we have considered as this term, that is k square d square minus 1, and here phi is minus y2, which is the right side of the equal sign. So now if we solve this, minus we can move here, so it will be 1 by 1 minus k square d square into y2, and we write like this, k square d square inverse y2. Now the formula, hope you can remember this binomial exponential. Through binomial exponential we can find out this, that is 1 plus x plus x square, like that. If I'm not wrong, let's check here. So yes, it is. Now similarly we can write this also. The first two term only needed, because then only we can understand what will come. So here we can see that 1 into y2 is y2, and here is derivative term. So y2 is constant. It is written in the question that k, y1 and y2 are constants. So if it is constant, so constant derivatives is 0 always, we know, hope we know. So remaining terms will be also 0. So it is y2. So particular integral will be y2. Now the total the solution will be y equal to complementary function plus particular integral. Now complementary function, we got that e to the power x by k plus c2 e to the power minus x by k, and particular integral is y2. Now there are some boundary conditions. There are some boundary conditions that we got. So let's copy that from here to understand it properly. I'm copying it and I am pasting it here. Paste. Okay. So if we write now here, for the first condition, y will be y1, and here x will be 0. So if I write in this x as x0, then the terms will be c1 only, and here it will be c2 plus y2. So this is the first equation we are getting from this first boundary condition, and from the second boundary condition we'll get y2 equal to c1 e to the power infinite plus c2 e to the power minus infinite plus y2. So this term will be obviously 0. Hope we know that, because c2 e to the power minus infinite equal to c2 into 1 by e to the power infinite c2 by infinite equal to 0, because if we in the means if we divide any number by infinite, then it will be surely 0. So here e to the power infinite is infinite. Hope you know that, because approximately I guess 2.7 the is value is. So and if we in the power, if we write infinite, then it will be obviously infinite term. So then the result will be c2 by infinite, result will be 0. So this term is 0. I have written here. And now y2 and y2 are there. So if I just simply cut this, then in the we are getting here c1 e to the power infinite equal to 0. So c1, obviously here you can see c1 will be 0. So c1 we are getting here 0. Okay, so we can write, means I'm just representing with other colors, so it will be easier. Like c1 we are getting, so we are replacing in this one equation with c1's value. So y1 equal to 0 plus c2 plus y2. Now now it will be c2 equal to y1 minus y2. Okay, Now let's write this in this equation. Okay, we can copy this. No, it will not be the correct one, so let's copy the whole thing here and right paste here. Now the solution will be so the solution will be here. C1 we got here 0, so first term will be 0, and C2 is y1 minus y2 and e to the power minus x by k plus here it is y2. Okay, so hope it is correct. Now let's check the solution. So it is above, so what we will do, we'll just copy these options and we will paste here. Now let's check. Here it is y1 minus y2 e to the power minus x by k plus y2. So option C is the right answer. Hope you will see and relate that. So right option is option C. Okay, hope you have enjoyed this video. If you have learned this properly, please comment, and so that we can understand that yes, we are going in the right direction. Thanks for listening. And one more thing I want to tell, that this videos I am preparing not for you only, for me also I am preparing, because I am also still an aspirant. So these videos will be helpful for me also. So I am preparing this video with my best effort, so that I also can revise this properly if I need. So I think it will be very helpful for you also. Please comment if it is helpful for you also, and if you want to give any suggestion, please give. And please sorry and excuse me for my mistakes. Hope I can recover this properly. Okay, thank you for listening.